So hello, this is Flavio. This is my first live code, although it's going to be recorded Haskell kata video that I'm posting. Maybe it will be the last one. I don't know. It depends much on your support. So please don't be too harsh with me. But I'm really excited about recording this kind of video, and I hope it goes fine. So I was prompted, or I felt the immediate need to record this video because I watched this video by Decoding, a YouTube streamer, Haskeller that I follow, and I really enjoyed his content and his videos, and I really appreciate that he does this kind of content, and I thought that it was exciting. So what I wanted to do is try to solve the same kata as he did, but obviously there are as many approaches to solve one problem as Haskellers or as developers are in the world. So I thought that his solution was like a bit too complex, maybe too complicated, and maybe it's because I come from JavaScript, but I have a different mindset, and also I learned Haskell after that. I would have solved it in a completely different way. So maybe this video will give you some insights, or maybe a different kind of thinking pattern. I hope it's useful for you as well. So the coding kata that we're going to solve is basically Morse codes. We're going to decode from Morse code to strings. And if we go to Code Wars, we see that this is the kata. It's 6Q, which is made with a Japanese leveling system. The lowest level is 8Q, and it goes 8, 7, 6, all the top to 1. And then it's not Qs anymore, it's Dan, like in Judo or Aikido or any other Japanese martial art. So this means that 6Q is fairly easy, but is not easiest problem that we can find in this platform. So let's see. We have our module, and the function that they want us to write is decode Morse. That obviously is going to receive a string and return a string. And we have a small test here, and we want to make sure that this Morse code is translated to Hey Jude. So I've prepared something which is kind of weird, but I've made a synthetic event. I have my own. I've prepared basically my own Haskell project to be able to work, and I've preloaded some modules that I'm going to explain later. And I've also cheated a bit and provided the same Morse codes map that they are providing, because they don't want us to care about the actual encoding of every Morse letter into strings. They provide that map to us, and so we don't have to care about that. We just have to care about the actual decoding of the Morse code. So let's start. And also, one of the interesting things about this kata is that they provide the data map strict and the exclamation operator. So what does this operator do? Well, basically, if we query for the type, this operator expects a map and then a key and returns a value. So we have our Morse codes map there, and we say we use it because it's an infix operator, and we say, for example, the dot operator, and it will return the E. But what about if we use something that is not a Morse code? Well, basically it explodes with an exception. So this is not a safe operator. That's why Soding, this Russian YouTuber, I hope he's Russian, I really don't know. He doesn't use this function. He uses data map lookup, which is exactly the same as this operator, but it's not an infix operator. It's just a regular function, and it returns a maybe. So the way this works is, let's see, data map lookup. It checks first the key, and then the Morse codes. And it will return a maybe of a string, in this case, because it is a Morse code, the letter E. But if it is not a Morse code, then it will just return a nothing. So this is a better option, in which is safest. But if the guy who created this kata on the code word side allowed us with this import, provided this import, we're going to trust that they are using good faith and they don't want to actually break our program. Let's see how that goes afterwards. So the first thing that I want to do, or I want to begin with, is that by definition, words in Morse codes are separated by 3 spaces and letters by 1 space. And Soothing solves it in a different way, but I thought it was too complex. So for example, if my definition of word is that it's something that is separated by 3 spaces, there's a function called split on. And as you see, it comes from data list split. And I'm going to say that is 3 spaces. And then I'm going to input this. Awesome. We're going to comment this type signature because we need it, but to the end, but we want to gradually see what's going on and build an intuition on that and test everything we do. So for example, now we have split everything into words. So I have also test. Let's see if I'm able to type Decode Morse test, and we have successfully splitted our sentence in Morse into words. Nice. But now, to be able to decode every single letter from Morse to strings, we need to be able to do it on the letter level. So we would need like another split again. What happens is that in Haskell, splitting words from a sentence or splitting by space and also joining by space is as common that we have our own functions, which are called words and words. I really don't know how to type. Okay, so how this function works. So words receives hello there, and it returns a list of strings. It uses the space as a separator, and if likewise we have a list of words, hey you, and we send it to unwords, we will receive back the strings. So we don't actually need to use again split, we can just use words. Perfect. So now what is happening? What is happening is that if you remember, we had a list of strings already, and words needs a string and it will return another list of strings. So in reality, what we need is to apply this function to the inner contents of our list of strings. And if you have seen any of Soothing videos, he also talks about the penetrating operator, which is Fmap. I think it's very funny, but I don't really think about functors or map that way. I think that if I need to lift a function over some structure, then I need to use Fmap. Okay, so what is happening right now? Decode Morse, in which step we are. Okay, now we finally have our list of letters. Perfect. And of course, Fmap works for every functor, but in this case, we are going to use the specialized version for lists, which is just map. And we skip 1 letter. We're going to try to write the shortest and concisest solution as possible. Let's see if that works out well. Again, decode test, it works the same, and now we can actually care about the translating to Morse codes. So what are we going to do? Well, obviously you might have guessed that we need another map by some function, and we're going to compose it. And this function is going to have something to do with Morse codes, that's where we need our map, and our operator. And why? Remember that if we query the type of exclamation, this is a function that expects a map and a key and returns its possible value. If not, it blows up. So if we use partial application to have Morse codes and apply it to this infix operator, what we get is a function from string to string, a function that we can pass to any functor to map its contents. So we're going to, we know this for sure, that we need to map, and we're going to use this function. But what happens now? If we reload, we're going to get an error that says, okay, I expected a string and as a return value a list of strings, and I got a list of strings. So this is becoming a bit of a nightmare, isn't it? Because we are dealing with functions that build lists, but we want to not have so many layers. So you might have been guessed already that we're going to use the idea or the concept of Flatmap. And for that idea, in Haskell we have two things. We have the concat-map function. I don't know why it is not called Flatmap, but it is not. And also we have the monad operator, which everyone knows, that is basically the same, but applied to monads, and it's an infix operator, so the order is flipped. But first, let's do something fun. So right now we're getting the same error as before. We're saying, okay, you are mapping something, but now we have a list within list, so we need to map twice to actually apply our mapping function to where we want to. So let's get a bit crazy with Haskell. And interestingly enough, if you decode Morse test. Perfect. So if you combine or if you compose two maps, this is like saying, okay, I want to lift this function but over two layers. And this can go on and on as long as you want to. So this is kind of like a crazy Haskell code. I hope no one actually does this, but it's interesting to know that we can compose maps this way. So as we see, we have an error, but it's just a warning from HLint. I will show you how great HLint is, but after a moment. And right now we have a list of strings, and every string individually represents the letter that we want to parse. And if you have noticed, we are no longer in Morse code. We are actually now on the alphabetic dictionary. We are using readable letters to human readable. Nice. So we're very, very close to make this work. But what we mentioned before, we don't actually want a list of lists. We want to use a function that will map this function and then unwrap the second list so that we have only a list of strings instead of a list of strings. So we have two options. We can either use the concat-map function, which works, or we can go fancy, and we said that we wanted to spare keystrokes, and we can use the monad bind operator instead. And it works exactly the same. So for the sake of keystrokes, we're going to, go with the monad bind operator. So this is very interesting. Why HLint gives us an error here? Well, it's just a suggestion. The suggestion is use map once. So if you have noticed, we're using function composition and we are mapping twice. And actually, I think the rule is a bit more beautiful if we use Fmap, because it says that what is happening actually is that we can benefit from the functor laws. Functor law replace Fmap with blah blah blah, which means basically, to sum it up, we are Fmapping by words once, and then we are composing with another Fmap, which means that there's one functor law that says that Fmapping twice and composing them is the same as composing once the functions that you want to Fmap over and then only Fmap once. So we're going to benefit from this HLint. As you see, it looks like we actually have like a very smooth IDE in Haskell right now, and it's really, really a pleasure to work with. So thanks to the GHC IDE people, the Haskell language server people, thanks to also to Neil Mitchell for HLint, because it's actually is awesome, it's incredible, and we are having a tremendous Haskell experience in the editor right now in Visual Studio Code. Okay, so we're one step further. Let's see. Right now we have our list of words that we wanted, and if you remembered, if we pass this to unwords, we will probably get what we wanted. Perfect. So now that's it. We should be done. Okay, so this should be the solution to our problem. Let's see if this actually works. Let's try it, and let's see if we're missing something. Our implementation goes here, and we need this import as well. And let's see what happens. Nice. So the first test, the initial test, hey Jude, is passing. Let's go with the final round of tests and see what happens. Boom! Exploding. If you remember, if you read the instructions for this kata, it says that extra spaces before or after the code have no meaning and shouldn't be ignored, which is something that actually we didn't have in mind. So what I did to solve this is I cheated again, and I provided a second test string which is a bit more malicious and adds trailing spaces at the beginning and at the end. So we're going to use this function to see what is happening. And you can see that, of course, our function doesn't work yet. So let's see what can we fix. Well, so it seems like the first part of our problem solution is fine, but it is returning empty strings. So this is something that we really don't like. And in Haskell, there's a function called null. So yay, we have nulls in Haskell, but not the null that you're thinking of. It's just a function that expects a foldable of some type and returns a bool. And for example, string is foldable. So if I say hello, this function is just like is empty, like in other programming languages. So what this is doing is, if a string actually contains something, it's not null. So this returns false. But if we pass it the empty string, then it's true. So we can benefit from this behavior to filter out the values that we don't care about. And let's do that now. Let's use filter null and add it to our composition. And with our current filter, we're filtering only the null values, which is something that we don't want. In Haskell, there is also, another higher order function. No, it's another function, just another function, regular function, that is called not, that would just return the inverse, the opposite of what we, if we pass it true, it will return false, and if we pass it false, it will return true. So we can use that in our filter and compose not null, which reads nicely in my opinion. And then if we try this again, that's it, we got it. We're filtering all the things that we don't care about, and this should be our final solution. So if you're wondering right now we can go back to our unwords. GHC Haskell server is saying that we are from having a string from a list of strings, we know. Okay, and now everything should work correctly. So decode Morse, let's see. Our test passes correctly, and our second test passes correctly as well. Let's see what Haskell rank, or no, not Haskell rank, but CodeWars thinks about this solution. Test. The initial test works fine. And then the final round of tests, drumroll, passes. We submit, and our solution works perfectly. So that was it. I hope it wasn't too hurtful to to enjoy this. I hope the solution made sense to you, and it's also that you think is logic. Maybe it's not the most performance solution, that's for sure, but I think it's nice because it involves a lot of functional composition and F mapping, and even discovering some of the functor laws. So I think it was, for me, at least, it was a very enjoyable problem to work on. This can become very crazy. You can use traverse, for example, instead of F mapping, or you can use different solutions with the data.map.lookup function. But we'll leave that to another episode, maybe, or to the Haskell coding wars that I plan to do with Alejandro, maybe in a next video, or in a stream on Twitch. We don't know. Hope you enjoyed it, and please share this video, or maybe follow on YouTube and Twitter. I don't know, but see you later.